They laughed when Rudolf Diesel walked into the boardroom of the Bush-Sulzer Brothers Diesel Engine Company in 1912. Not at him, exactly. At the machine he wanted to put in a locomotive. The diesel engine had been around for 15 years by then, powering stationary generators and marine vessels, but everyone in railroading knew it would never work for trains. Too heavy. Too slow to respond. Too unreliable for the constant stops and starts of switching work, let alone mainline service. Steam ruled the rails, and steam always would. Within 40 years, steam was extinct on American railroads. The diesel locomotive didn't just replace it, it erased 100 years of infrastructure, expertise, and industrial culture. The story of how that happened isn't about one inventor or one breakthrough. It's about timing, economics, and the willingness of a few engineers to ignore what everyone knew was impossible. The diesel engine itself was brilliant but impractical for railroad use. Invented by Rudolf Diesel in 1893, it compressed air to such high temperatures that fuel ignited without a spark. More efficient than steam, more powerful than gasoline engines. The problem was weight. Early diesel engines produced maybe 10 horsepower per ton of engine weight. A locomotive needed hundreds of horsepower. The math didn't work. You'd need a diesel engine so massive it would crush the frame it sat on. Then there was the transmission problem. Steam locomotives transmitted power directly to the wheels through connecting rods, pure mechanical force. A diesel engine spinning at 1,500 revolutions per minute couldn't do that. You needed some way to convert that rotational power into the kind of force that could move a 1,000-ton train from a standing start. Mechanical transmissions like those in trucks couldn't handle the load. Hydraulic systems existed but were inefficient. Electric transmission, using the diesel to power a generator that fed electric motors on the axles, seemed promising, but no one had made it work reliably at railroad scale. The General Electric Company had been experimenting with diesel-electric technology since the early 1920s, building switcher locomotives for industrial yards where their limitations didn't matter much. These were small, relatively low-power machines meant for moving rail cars short distances at slow speeds. They worked well enough in that narrow application. GE sold a few dozen. Railroads found them useful for yard work, where steam switchers had to maintain steam pressure all day, even when idle, burning coal and water continuously. A diesel could shut down between jobs. Operating costs dropped. The executives at Electro-Motive Corporation saw something everyone else missed. Founded in 1922 as a manufacturer of gasoline-electric rail cars for short-run passenger service, EMC understood something fundamental about railroad economics that the traditional locomotive builders, Baldwin, Alco, Lima, didn't want to acknowledge. Railroads weren't really in the business of moving trains. They were in the business of moving freight and passengers as cheaply as possible. Steam locomotives were magnificent machines, but they were also incredibly expensive to operate and maintain. A steam locomotive required a crew of at least 2, an engineer and a fireman. The fireman's job was to shovel coal, literally shovel, ton after ton, shift after shift. A single locomotive on a long haul might burn 12 tons of coal. That coal had to be loaded, transported, stored, and shoveled. Water had to be taken on at regular intervals. Boilers had to be cleaned of scale buildup. Fireboxes needed maintenance. Running gear, all those exposed rods and pistons and valve gear, required constant lubrication and adjustment. Steam locomotives spent nearly as much time in the shop as they did on the road. Diesels promised to change all that. No firemen needed. No coal. No water stops. No boiler maintenance. An electric transmission had fewer moving parts than steam valve gear. In theory, one diesel locomotive could stay in service longer, run farther between shops, and cost less per mile than steam. In theory. The problem was building a diesel locomotive powerful enough to replace a mainline steam engine. EMC hired two men who would solve that problem: Richard Dilworth and Harold Hamilton. Dilworth was an engineer who'd worked for Alco building steam locomotives before jumping to the diesel side. Hamilton was a designer with a background in marine diesel engines. Neither was interested in building a better switcher. They wanted to build a diesel that could pull passenger trains and, eventually, freight across the continent. The railroad industry thought they were wasting their time. In 1934, EMC demonstrated the first diesel streamliner, the Burlington Zephyr. Sleek, stainless steel, powered by a diesel engine built by General Motors. Motors' Winton Engine Division. GM had purchased Winton and Electro-Motive by this point, combining them into what would become the Electro-Motive Division. The Zephyr wasn't a locomotive in the traditional sense. It was a three-car articulated train set with the diesel engine and generator in the leading car, driving electric motors on the trucks beneath. It looked like nothing else on American rails, a gleaming Art Deco bullet compared to the black iron of steam. The Burlington Railroad ran the Zephyr from Denver to Chicago non-stop, over 1,000 miles, averaging better than 70 miles per hour. It arrived 13 hours after departure, breaking every speed record for the route. Newspapers covered it. Crowds gathered at stations to watch it pass. The railroad industry called it a publicity stunt, a lightweight toy train that couldn't handle real railroad work. They were partly right. The Zephyr was a proof of concept, not a solution to freight hauling. But it proved something important. Diesel power could compete with steam on speed and reliability. What railroads really needed was a freight locomotive. Passenger trains were glamorous, but not where the money was. Freight was the backbone of railroad revenue. Coal, grain, manufactured goods, raw materials moving in 100-car trains across the country. Those trains needed power. A typical steam locomotive like the 282 Mikado produced around 50,000 pounds of tractive effort. Could a diesel match that and still maintain the reliability advantage? EMC's answer was the FT, introduced in 1939. Not one locomotive, 4 units coupled together, each with a 1,350 horsepower diesel engine. Total, 5,400 horsepower. More importantly, all that power was usable at any speed. Steam locomotives had a fundamental limitation. Their tractive effort dropped dramatically as speed increased. A steam engine was strongest at starting and weakest at speed. Diesels delivered constant horsepower across their operating range. 4 FT units together could match or exceed the pulling power of the largest steam locomotives and maintain it at 40 or 50 miles per hour, where steam engines struggled. EMC built a demonstration set, 4 FT units in the now iconic freight livery scheme, and sent it on tour. The plan was simple: let railroads use it for free, haul their freight, prove the economics. For over a year, the FT demonstrator logged over 83,000 miles on 11 different railroads, pulling everything from coal drags to time-sensitive reefers. Maintenance crews documented every detail: fuel consumption, repair time, availability, cost per mile. The numbers were undeniable. The Santa Fe Railway was the first major buyer, ordering diesel freight locomotives even before the demonstration tour ended. Other railroads hesitated. World War II intervened, and the War Production Board restricted locomotive construction to essential military needs. Most of what EMD built during the war went to the U.S. Army or to essential freight operations. But those wartime restrictions also froze steam locomotive production. Railroads had to make do with what they had, and that meant running aging steam engines harder than ever. Maintenance costs climbed. Availability dropped. The economic case for diesels got stronger every month. After the war, the floodgates opened. EMD couldn't build diesels fast enough. The F-Series freight units and E-Series passenger locomotives sold by the thousands. Baldwin and Alco tried to compete with their own diesel designs, but they were years behind EMD's engineering and manufacturing capability. More importantly, they were culturally behind. Baldwin and Alco were steam companies trying to build diesels. EMD was a diesel company from the ground up. The transition happened faster than anyone expected. In 1945, steam locomotives outnumbered diesels 20-1 on American railroads. By 1955, the ratio had reversed. Steam construction stopped entirely. Baldwin closed its locomotive works. Alco limped along, building a few thousand diesels before giving up. EMD dominated the market so completely that diesel locomotive and EMD became almost synonymous. What died with steam wasn't just a technology. It was an entire industrial ecosystem. Thousands of coal mining jobs disappeared as railroads stopped burning millions of tons annually. Water towers came down. Roundhouses, massive circular buildings designed for turning and servicing steam locomotives, sat empty, then were demolished. The skilled crafts of boiler making and steam fitting became obsolete. Engineers who'd spent decades learning the temperament of steam found themselves retraining on diesel systems they didn't trust and didn't like. Towns that had grown around division points, where steam locomotives stopped for servicing every 100 miles, withered when diesels ran straight through. The romance of railroading changed. No more fire and smoke and hissing steam, just the steady hum of diesel generators and the whine of traction motors, cleaner, quieter, more efficient. But also, in some fundamental way, less alive. The economics were irrefutable. A single diesel unit required a third of the maintenance hours of a steam locomotive. Multiple diesels could be coupled together under the control of one engineer, something impossible with steam. Diesels didn't need to stop every 100 miles for water and coal. They could run 1,000 miles or more on a single tank of fuel. Operating costs dropped by 40% or more. For railroads struggling with post-war competition from trucks and airlines, that savings meant survival. Rudolf Diesel never saw any of this. He died in 1913 under mysterious circumstances, falling from a ship crossing the English Channel. Whether accident, suicide, or murder, no one knows. His engine lived on, but it took 30 years and the work of hundreds of engineers to make it practical for railroads. The joke is that Diesel invented the engine, but EMD invented the diesel locomotive.